Hi, I'm David with General Air. I've made a video before about welding thin steel using self-shielded FluxCore wire, but I wanted to take another look at it. So today we're going to be welding 16 gauge base plate with Lincoln NR211 self-shielded FluxCore wire. The first thing that we need to do is get our machine set up. Now, one thing to note here, self-shielded FluxCore wire, like the kind we're using in our 211, runs on DC electrode negative. So if you typically use your machine for MIG, which will be set up positive, you'll want to change that before you start to weld with this wire, or you won't get any good results at all. So now let's talk about wire feed speed and voltage. Now I'm using an inner shield wire guide that's published by Lincoln Electric, the same people that made our wire. And when I open this guide up, I know it's kind of hard to see the text in here, but it tells you everything that we need to know from our polarity to our contact tip to work distance, and also the wire feed speeds and voltages that are going to be appropriate for this wire. Now, we're going to be welding on some thinner material, so I'm going to choose a wire feed speed that's going to produce me a lower amperage. So I'm going to go with 70 inches per minute and 15 volts. We've got a range on our voltage we can use, 15 to 16 volts, but if we remember what voltage does, it lowers our arc length. And I'm trying to get a small little weld out of this, so I'm gonna go with the smaller or the lower voltage. I'm gonna set my material up with just a little bit of a gap in between. This is gonna make it a little bit more difficult because if I just butted them together, well, then the two parent metals can share the heat load and it won't be as impactful. So we're gonna spread these apart, tack them here and here, and then we'll weld them up. I want to weld my plate in a couple different positions so we can see some different scenarios. The first one I'm going to do is going to be vertical. I'm going to hold my gun in an upward angle and then I'm just going to drag it down this seam. And if I have my wire feed speed and voltage set correctly, I should just be able to walk it all the way down. I'm going to make about 1.5 inch weld here. If my wire feed speed is too high, which means my amps are too high, which means I have too much penetration, then I'll just blow right through and then we'll have to adjust our wire feed speed from there. All right, here's our two welds. This is the vertical weld and this is the flat weld. And I didn't like the vertical weld. The procedures were a little bit too high. I had a little bit too much amperage and it was pushing through the plate. We can see the backside really smeared around and both surfaces are concaved, which is not what we want. And I have a little pinhole here. I didn't really like that. But when I switched to my flat weld, I turned my procedures down. I turned the wire feed speed down to 50 and my voltage down to 14. That's as low as the book recommends you run this wire. And I got a much better result on this side. Back side of the weld also looks quite a lot better. So let's try those same procedures here, only here, but we'll put it back in our vertical position and see if we can get a nice looking weld. That was quite a lot better. Here's that last vertical weld that we did at the lower procedures. Let's look at the back side, and not surprisingly, we didn't get as much penetration as we did when it was in the flat. That's because gravity is pulling that weld down on our plate, and we're moving a lot faster than we are when we're in position. There's a definite technique when welding with FluxCore, especially flat like this. And there's a saying, if there's slag, you drag. So if I'm right-handed, I'm moving from my left to my right. If I'm left-handed, I'm moving from my right to my left. This allows the slag that's produced from the flux that's inside our FluxCore wire to float to the surface and we can chip it off and it doesn't get stuck in our welds. Like over here, that little pinhole that we had was some of the slag that didn't quite eject itself out of the weld. The other thing we really have to pay attention to is contact tip to work distance. With this FluxCore wire, we only want to be sticking that wire out around 1/4 inch. I've got to make sure that stays nice and tight, especially when I'm running this wire in our lower amperage and our low procedures. Let's destructively test this coupon. We're going to fold it in half in the vise and see if our welds will perform. With steel, the weld is usually stronger than the base material. Unless our weld is defective, we should be able to bend this all the way over. As you can see, the welds survived. They performed like they should. The base material deformed around, but the welds were unaffected. Now, the last thing I want to do to test these welds out is we can see that there's a lot of spatter and some smoke and discolorization from the flux cord wire. So what I want to do is take a flap wheel and grind all these down and see if we can get this down to nice, bright, shiny metal with no holes or pockets or anything like that. Now we have our sample ground flush, and you can clearly see the first weld that we did with the higher procedures, that was 70 inches per minute at 15 volts, it trapped a lot of slag. All these little pockets are slag and places where the slag kind of popped open and left these ugly holes. But when we turned the procedures down and got a smoother weld, I did have one little pinhole right here, but that would be pretty easy to fix. But the rest of the weld stays pretty smooth. Now, FluxCore is not my first choice for doing thin material. Certainly solid wire, short circuit MIG is, but if you only have FluxCore, you can certainly make it work. I like FluxCore wire. It's one of my favorite things to weld with. And when we know what wire feed speed and voltage actually do, wire feed speed being the thing that controls our amperage, or how much punch we get into our material, voltage being the thing that controls our arc length or the bead profile, then we can flex our flux cord wire to do things that it's typically not very good at, like thin material. Also using our resources, like the wire guide that I used from Lincoln Electric. It tells me roughly what wire feed speeds and voltages I should start off with. Now I've got a ballpark figure and I can tune my machine in from there. Thank you for watching. If you like our videos, please subscribe. And if you want more information on general air, surface, and supply, head over to our Facebook page where you can like and follow us there.